Okay, honors, you ask and you shall receive. So here's a couple honors level questions involving special right triangles. So we need to find these four variables, A, B, C, and D. Okay, so now notice these are two triangles connected to make one big triangle. And those two triangles are a 45, 45, 90, and a 30, 60, 90. Okay, so because of this, we need to think of this in two phases, right? Now, notice here, they give you this measurement right here. So we need to focus on the 45, 45, 90 triangle first. So you'll see I just draw it here. So this was 7 square root of 2. Here was one of the 45s. This is a right angle. This is C. This is A. So in a 45, 45, 90 triangle, the two legs are S and S. Hypotenuse is S square root of 2. So we need to find A and C, which are the values of S. They give us what S square root of 2 is. S square root of 2, is equal to 7 square root of 2. So simply divide both sides by the square root of 2. They cancel here. There's your S. And now what's nice about how this problem was set up is that they also cancel here. There's no rationalizing. Your S is just 7. So your value of A is 7 and your value of C are both 7. So over here in these boxes, I would just put 7 for A and 7 for C. And now we can use the value of A being 7 to then transfer us to the second triangle, which is a 30, 60, 90. And I'll do it down here. So here is that triangle, 90. Again, this is your A value, which is now 7. This is D. Here's 30 degrees. Here's B. And of course, that's 60. So 30 degrees points to the shortest leg, S. Right angle points to the hypotenuse, 2S. And then the third side is S square root of 3. Well, lucky for us, we know what S is. S is equal to 7. D and B are both equal to their own thing. B is equal to 2S. So B is equal to 2 times 7. So B is 14. And D is equal to S square root of 3. D is equal to 7 square root of 3. And that's D. So B is 14. And D is 7 square root of 3. There we go. Okay, next. Okay, so now we have a trapezoid, right? So a trapezoid is made up of a rectangle and a triangle or triangles. So in the case, this one is made up of one triangle. If we draw that dotted segment that breaks the triangle from the rectangle, here we go. And notice that the number they give us is right here, 2 square root of 3. So we should know that the opposite sides of a rectangle are congruent. So this side is also 2 square root of 3. If these are right angles, this is a right angle as well, which means that this is a right angle and this is a 30, 60, 90 triangle. Let's bring that over here. I'll make it a little bit bigger so we can write it. So this is A, this is 90, your 60 is here, so your 30 is up here. And again, we brought over 2 square root of 3. Now, to find A, we can do that directly. To find B, we're going to have to do that indirectly using this 6. This 6 goes across the bottom. So we'll talk about how we do that in a second, okay? So in this picture, this would be 30. So 30 points to the short leg S. Right angle points to the hypotenuse 2S. And then this is the third side, S square root of 3. So we need to find A. So A is 2S. Well, to find 2S, we need S. And to find S, we start here. S square root of 3 is equal to 2 square root of 3. Divide by the square root of 3, divide by the square root of 3. And just like last problem, your S comes out to be a nice number of 2. So S is 2. So this length right here is 2. Well, then what is A? Well, A is double that. A is 2S. So A is 2S. A is 2 times 2. So A is 4. There's A. But now how do we find B? Well, remember, this is a rectangle. If that's B, so is that length. B plus 2 equals 6. So if we know the entire length up here is 6, and we know this part is 2, to find b, just take 6 minus 2. And b is also 4. What a coincidence. So a is 4, and b is 4. So again, with these trapezoid problems, just break it up into the rectangle and the triangle, special right triangle, and go from there. All right, good luck.